Here's rectangular. This is polar. The difference between these are in rectangular, everything's made in a horizontal or vertical grid. Right. In polar coordinates, it's concentric circles. Look at now, what are polar equations? What is an equation? From algebra, what defines an equation as opposed to an expression? It has an equal sign. It equals something. An expression is simply a statement. So the polar equation is an equation whose variables are polar coordinates. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. One method of doing this is converting from polar to rectangular, because we're used to drawing and graphing rectangular coordinate systems already. So that's one possibility we can go through. Here's our first example. Identifying and graphing a polar equation. Also, I mean, in rectangular coordinate systems, when you graph it, it's just a dot. When you graph polar equations, you're looking at circles. So here are the steps. Usually we square both sides. Because when we square both sides, if we have r, we're trying to get to r equals x squared plus y squared. That's our first goal. Graph the circle by moving the ray. by theta degrees or radians from the x-axis. Graph the point by extending the distance r from the origin. R units. These are the steps. So this is example 1. Our example is r equals 3. Because if you just said radius equals 3, what does that mean? But now what would the graph look like? It's not a line. If it's a radius, it's circles, but that's what it means. So that's why I said, let's convert it to rectangular coordinates. So first step, square both sides. So r squared equals 9. Conversion, what does r squared equal? I should leave it like this, 3 squared, because it tells us a lot more. If we put 9, then we have to take the square root of it to find the radius. So what's the center of this equation? Of this circle? This is an equation of a circle. Remember, a circle looks like x minus h squared, y minus k squared equals r squared. That's the equation of a circle. There is no h and k. What's that?
C would be 0.
Be 0, 0, correct. And the radius, it's whatever's under the skirt, equals 3. So if we graphed this, our center is at the origin, at the pole. We go out 3, all directions from there. And we connect the dots. So there's our graph from radius equals 3. Yeah, but now looking back, if it says radius equals 3, the radius belongs to a circle. So we have a circle radius 3 centered at the origin. Because it's polar coordinates, it's always at the pole. Example 2. ID and graph theta equals pi over 3. Okay, things a little bit different here. Here are the steps for this one. Because think of it. If we say theta equals pi over 3, what does that do with our graph? Remember what we did earlier? What does that do with our graph? It lifts up the terminal side from the polar axis up to wherever it is. So we have to find the equation of the line from the given information then take the tangent of both of that angle of both sides. But we know that tangent theta equals y over x. And then solve for y. So in this one, we have theta equals pi over 3. Take the tangent of both sides. Tangent theta equals tangent of pi over 3. Tangent theta is equal to what? Y over x. That's what we put there. What is the tangent of pi over 3? Over 3, very good. And then solve for y. So y is equal to x radical 3. So what is that graph going to look like? A linear equation goes through the origin, since there's no plus or minus to it. When x is 0, y is 0. When x is 1, it's radical 3. And it goes on both directions. It's an equation of a line. But this is also the same line where it gives us a terminal side of theta equals pi over 3. The next one. Identify and graph the polar equation as a horizontal line. Here are the steps. ID, identify the rectangular conversion. Second, then transform x is equal to r cosine theta, y equals r sine theta. If the equation is simply this, if it's x equals, then it's a vertical line. If it's y equals, then it's a horizontal line. So the equation we're using for this example is R equals, well, no, R sine theta equals 2. So identify the rectangular conversion. What do we notice about this equation here? Do you notice anything there? R sine theta is the same thing as Y, so Y is equal to 2. There is the line. It's a horizontal line crossing the Y axis at there's the graph. Example 4. ID and graph a polar equation as a vertical line. In this example, we're saying R cosine theta is equal to -3. Same steps as the other one. R sine theta equals X. So X equals -3. So therefore your graph is a vertical line at -3. Tons of more steps to go. There are all different types of combinations we can do. All right, so that's class times 50 minutes after. We'll finish up this section next time. And if we have